Binomial expansion. This is a topic that you'll meet at A level. In Edexcel, it's Core 2 Chapter 5, and in IB, it's Chapter 7. Binomial expansion refers to the process of expanding expressions in the form of a plus b all to the power of n. For example, a plus b all squared would give you a squared plus 2ab plus b squared. A plus b cubed, well, that's like multiplying our last expression by a plus b. So when we expand this, we know that that's a squared plus 2ab plus b squared. So multiplying everything by a gives us a cubed plus 2a squared b plus ab squared, because I have all three terms multiplied. Multiplying everything by b would give me a squared b, 2ab squared plus b cubed. When I collect all of this together, I get a cubed plus 3a squared b plus 3ab squared plus b cubed. If I expand more, you can see a pattern. So a plus b just gives me a plus b. We've done a squared and a cubed. And if I were to expand a plus b to the power of 4, I'd get a to the power of 4 plus 4a cubed b plus 6a squared b squared plus 4ab cubed plus b to the power of 4. You can already see some patterns. We already have a, and you can see there's an increasing power, and at the other end we have b in an increasing power. So let's look at the coefficients, the number in front. If I were to put a 1 in front of all of the numbers that didn't have a 1 in front, you can see the pattern more clearly. And this forms a triangle. This is called Pascal's triangle. I'll just go back so you can see how that fitted in. So Pascal's triangle works like this. The next term is created by adding the previous two terms together. So you can see here 1 and 3 make 4, 1 and 1 make 2, 2 and 1 make 3, 3 and 3 make 6. And this forms a pattern. So if I take the fourth line here, 1, 4, 6, 4, 1, you can see that this makes 1, 4, 6, 4, 1. The power of A also descends. So it goes 4, 3, 2, 1, and then 0. The 1 would just be A, and anything to 0 is 1, so that would sort of essentially multiply by 1 or sort of disappear. The power of B descends, so we have 0, 1, 2, the power of B ascends, we have 0, 1, 2, 3, 4. Again, b to the power of 0 is just 1, and b to the power of 1 is just b. So I can expand my term here, and then adjust to get the final answer. So let's have a look at a plus b to the power of 5. I'll need the fifth line from Pascal's triangle, so 1, 5, 10, 5, 10, 5, and 1. So we can put that in place. My a descends, so it starts with a to the power of 5, and then goes 4, 3, 2, 1, and 0. My b ascends, so I would need 0, 1, 2, 3, 4, and 5. So I can take out the 1s on either end. I can take out the b to the 0 and the a to the 0, and I can take the 1 off the b and the a, which leaves me with my final answer here. So a plus b to the power of 5 equals a to the 5 plus 5a to the power of 4b plus 10a cubed b squared plus 10a squared b cubed plus 5a b to the power of 4 plus b to the power of 5. So we can use this expansion for any expression. So let's say instead we had x minus 2 all to the power of 5. Well, in this case, a would be x and b would be minus 2. Be really careful to keep in the minus 2. So using the expansion from above, every time we have a, we'd put in x, and every time we have b, we'd put in minus 2. So we'd have x to the power of 5 plus 5x to the power of 4 times minus 2 plus 10x to the power of 3 minus 2 squared plus 10x squared minus 2 cubed plus 5x minus 2 to the power of 4 plus minus 2 to the power of 5. Be very careful that when you square minus 2 you get a positive, and if, for example, if you cube minus 2 you would get a negative. But when you multiply all this out, this would give you your final answer.